Imagine a tiny metallic emissary, a testament to human ingenuity, no bigger than a small car. It was flung from our world with the force of a titan's throw, a controlled explosion propelling it into the unknown. This is Voyager 2, launched in 1977, a time when disco reigned and personal computers were just emerging. It was a marvel of human ingenuity, a culmination of years of planning and tireless work by countless engineers and scientists. It was sent on a grand tour of the outer solar system, a mission of exploration and discovery. This was a cosmic billiards shot, a carefully calculated trajectory. The mission leveraged the gravity of giant planets to slingshot from one to the next, saving fuel and time. Voyager 2 gave us our first close-up views of Uranus and Neptune, icy giants previously only seen as blurry dots through telescopes. It revealed worlds of swirling blue and unimaginable cold, with winds that howled at supersonic speeds. For decades it sent back data from the frontier, painting a picture of the outer solar system in unprecedented detail. It survived radiation belts, the intense bombardment of charged particles around Jupiter, rings, delicate and intricate systems of ice and dust particles, and the vast dark expanse between worlds, a cosmic ocean of emptiness. The probe became a symbol of our reach for the stars, a testament to our insatiable curiosity. It was carrying a golden record, a message in a bottle from humanity to the cosmos, filled with sounds and images of our planet. But the grand tour was just the beginning, the initial phase of a much longer journey. The true adventure began when Voyager 2 left the planets behind, venturing into the uncharted territory beyond Neptune. It was heading for a boundary, the edge of our solar system, where the sun's influence wanes. Its destination? The point where the sun's influence fades and interstellar space begins, the heliopause, a region of dramatic change. This was a place no human-made object had ever reached with its instruments still active, a true first in space exploration. Voyager 2's journey is a story of hope, patience, and curiosity, a testament to the enduring human spirit of exploration. It's a multi-generational quest, spanning decades and inspiring countless individuals. With every faint signal of victory, a confirmation that the little ship is still sailing on. It's a whisper from the void, a faint echo of our presence in the vastness of space. We are a species that looks up, that wonders, driven by an innate desire to understand our place in the universe, and we dare to send a piece of itself into the infinite night, just to see what's there, to unravel the mysteries that lie beyond. The solar system, with its familiar planets and comforting sun, might seem like an isolated entity. But it's not an island at all, but a bubble, the heliosphere, a protective region created by our star. This vast bubble is carved out by the sun's powerful magnetic field and the constant stream of particles known as the solar wind. Inside this heliosphere, we're largely shielded from the harsh realities of the galaxy, the potentially harmful cosmic radiation and interstellar particles. For all of human history, everything we knew, everything we experienced existed within this protective cocoon, this solar sanctuary. Crossing its boundary, the heliopause, the very edge of the sun's influence, is more than just traversing a vast distance. It's a profound shift in environment, a transition from the familiar to the utterly unknown. On November 5, 2018, after decades of travel, Voyager 2's instruments registered a dramatic and unmistakable drop in the concentration of solar particles, a clear sign the wind was no longer blowing. Simultaneously, there was a significant spike in the detection of galactic cosmic rays, high-energy particles originating from distant supernovae and other cosmic events. It had crossed the line, venturing beyond the protective embrace of our sun. For the first time in human history, we had a direct line to an emissary in interstellar space, a lone sentinel sending back data from the great unknown. It was ready to answer fundamental questions about the space between stars, questions that had previously only been the subject of theory and speculation. Why does this matter, this crossing of an invisible boundary? Because the nature of interstellar space, its composition and characteristics, directly shapes the long-term habitability of our solar system and potentially life on Earth. The interstellar medium is the very stuff from which stars and planets are born, the raw material of the cosmos. It's the galactic sea through which our solar system travels, a journey that spans billions of years. Voyager 2's crossing gave us our first direct taste, our initial close-up view of this new and mysterious realm. It was like tentatively dipping a toe into a vast cosmic ocean, feeling the temperature and salinity of an alien sea. The probe, a testament to human ingenuity, became our sensory organ. extending our perception far beyond the familiar domain of the sun. It was no longer just passively observing from a distance, it was actively feeling the pressure, tasting the composition, and listening to the faint whispers of the space between the stars. The little ship, a tiny speck against the backdrop of infinity, was now our witness to the universe unfiltered, raw, untamed, and full of untold secrets. As Voyager 2 ventured deeper, suspense built within the scientific community. Models predicted a smooth transition, but space is rarely so simple. Some feared the interstellar medium was not a gentle sea, but a turbulent frontier, where immense cosmic forces clashed. The probe is now over 13 billion miles away. Each signal takes over 20 hours to reach us. Every packet of data is precious, each silence filled with anticipation. Would Voyager 2 confirm our models, or force us to confront a universe far stranger than we imagined? This is the nature of true exploration, a step into the dark, driven by curiosity and the unknown. The probe is our scout on the front line, and we can only wait, listen, and hope to understand the whispers it sends back. Then something unexpected happened. In 2024, NASA scientists noticed Voyager 2's orientation subtly shifting, as if pushed by a cosmic current. This wasn't a malfunction, the change was external. The probe was being deflected, its plasma wave instrument registering off-the-charts readings. It was like hitting a wall of water in space. The plasma density was increasing far faster than predicted. Telemetry confirmed it. The probe was decelerating, fighting against a growing current in the interstellar medium. The boundary of our solar system was not passive but a dynamic, interactive zone. The interstellar medium was dense, turbulent, and pushing back. This discovery sent shockwaves through astrophysics, revealing a powerful environment resisting our intrusion. The whispers of a complex, violent reality just outside our door were now a clear, loud signal. Voyager 2 had become our messenger from a universe more dynamic than we ever imagined. For years, some scientists theorized a hydrogen wall at the edge of our solar system, a buildup of neutral hydrogen where the heliosphere pushes against the interstellar medium. The fear wasn't just that this wall existed, but that it could be far denser and more turbulent than predicted. If the interstellar medium was clumpy, our solar system might be plowing into dense, energetic clouds. Such a wall could compress our heliosphere, letting more dangerous cosmic rays leak in. A long-term threat to life on Earth. Another concern, the sun's magnetic field and the galaxies might clash at the boundary, creating a chaotic zone of intense turbulence. This magnetic froth could act as a particle accelerator, energizing cosmic rays and funneling them inward. In essence, our solar system's journey through the galaxy might not be peaceful, but a collision course with violent, high-pressure shock fronts. The stability of our cosmic cocoon was suddenly in question. Voyager 2's signal painted a dramatic, unsettling picture. Plasma density readings soared, 40 times higher than just after crossing the heliopause. The probe had flown into a wall of gas, confirming the hydrogen wall's existence in spectacular fashion. Magnetic field data showed a region of intense turbulence, fields compressed, twisted, and tangled. The sun's and galaxies' magnetic fields were not merging peacefully, but locked in a violent struggle. The cosmic ray instrument registered a surge in galactic cosmic rays, suggesting the wall was filtering and accelerating particles. The heliosphere was being squeezed, its protective barrier under pressure. Voyager 2's data confirmed our greatest fears: a dense hydrogen wall, turbulent magnetic froth, and a compressed heliosphere. The probe's signal was no longer a whisper, it was a clear, urgent message. The universe beyond our home is not benign, it's a dynamic, high-pressure environment pushing back. Science often speaks in numbers, but Voyager 2's message is visceral. Imagine our solar system as a boat, the sun its engine, sailing through calm seas, until Voyager 2 reaches the edge of a cosmic hurricane. The waves rise, the winds pick up, and the pressure builds. The boat slows, pushed back by the storm. This wall isn't solid, but a region where matter's density suddenly increases, like walking from air into water. Voyager 2 is flying through a cosmic fluid, vastly thicker than the space inside our solar system. The data is clear: plasma density up 40-fold, magnetic fields chaotic, cosmic rays surging. These are not theories. They're direct observations from the front lines. When we say Voyager 2 turned back, it's a metaphor for a profound physical reality. The probe's signals are hard evidence, transforming speculation into fact. The echoes from Voyager 2 are a wake-up call, written in the language of physics. Across the vast gulf of space, Voyager 2 continues its silent vigil. Its faint radio signals, weakened by unimaginable distances, carry a message etched in the very fabric of the cosmos. It's a message both terrifying and profound, a stark reminder of our place in the grand cosmic scheme. It speaks of vulnerability but also of resilience. We are not isolated, adrift in some empty void. Our solar system is intimately connected to the galaxy, a swirling island of stars and cosmic dust. We are bound to it by gravity and the very laws of physics, subject to its weather and currents, the ebb and flow of interstellar tides. Our protective heliosphere, that invisible bubble shielding us from the worst of cosmic radiation, is not immutable. It's a dynamic shield, constantly flexing and reforming in response to the forces around it. And now, it's engaged in a struggle with powerful external forces, a cosmic tug-of-war with implications we are only beginning to understand. This has profound implications, reaching far beyond the realm of astrophysics. As we orbit the Milky Way, a journey that takes hundreds of millions of years, we'll inevitably pass through different interstellar environments, each with its own unique characteristics and challenges. Voyager 2 suggests we're entering a denser, more turbulent region, a cosmic cloud of gas and dust. This could have potential consequences for our climate, influencing weather patterns and atmospheric conditions. Our technology, so reliant on the stability of our space environment, could also be affected, and even the delicate balance of our biology could be influenced by these changes. But this is also a triumph of curiosity and ingenuity, a testament to the human spirit's unyielding desire to explore. We only know of this danger, this shift in our cosmic neighborhood, because we dared to look, to venture beyond the familiar. Knowledge, even when frightening, is power. It allows us to anticipate, to adapt, and to overcome. By understanding the challenges ahead, by mapping the interstellar currents, we can begin to prepare for the future. The cosmos is far more complex and challenging than we ever imagined, a tapestry woven with mysteries and potential dangers. It's calling us to be more vigilant, more curious, and more united in our pursuit of knowledge. Voyager 2's lonely journey, a beacon in the darkness, brings a message for all humanity, a message of both warning and hope. Our journey through the universe has only just begun, and the challenges we face will only make us stronger. We stand at a new kind of shoreline. Voyager 2 has shown us the waves are breaking at our feet. The boundary of our solar system is a dynamic coast, where the calm of our heliosphere meets the turbulent ocean of the galaxy. We are not just observers, but travelers navigating cosmic weather we're only beginning to chart. The universe is not just out there, it's an environment we're in. This knowledge inspires awe and humility, reminding us our stability is a delicate balance. As we move, our environment changes. Astronomy and exploration are essential for our survival. We must keep sending probes, building telescopes, and listening to the whispers from the dark. Voyager 2 has given us our first weather report from beyond the shore. A storm is brewing. Our task is to build lighthouses and draw maps for future generations. The journey continues.